For loops are fundamental in programming, and the C language is no exception. Many beginners learn the classic pattern like this: initialize the counter, test the condition, increment the counter, and do stuff. This is a common and perfectly fine way to iterate over n elements. But in C, a for loop is much more powerful than the simple pattern. This video gives a fuller look at how the for loop works and how to use it effectively. Here's the textbook definition. By the way, this is classic C from Kernighan and Ritchie. Expression 1 is evaluated only once, before the loop starts. Expression 2 is evaluated before each iteration. If it is false, the loop exits. And expression 3 is evaluated after each iteration. Therefore, it is equivalent to the following while loop. Any valid expression can be used, and all three expressions are optional. The body can be an empty statement, and you can write an endless loop that does nothing, which is not particularly useful. But if you want to skip the initialization, you can. You can also use the comma operator inside the expressions to handle multiple counters or perform other operations, because you don't actually need a counter in a for loop. Let's rewind to where we were. A declaration inside the init expression is allowed in modern C, and it is considered good practice. In that case, the counter variable scope is limited to the loop, so the two I variables are actually different variables. Choosing a counter type int is the natural first choice. However, when iterating over arrays or other collections, size t is appropriate. Size t is the unsigned integer type used for sizes and counts in many standard library interfaces, and it is the return type of size of. Using an unsigned type for a countdown loop can lead to subtle bugs. For example, this pattern is problematic. Here the condition I is greater or equal to 0 is always true, because I is unsigned. The correct approach is to test against a non-negative bound. I is always greater than 0. Note that inside the loop, you must index with I minus 1 in that case. An even better pattern is to decrement inside the test and not in expression 3. The decrement operation will be executed before the loop body, and the first iteration will run with I equals n minus 1. Both approaches properly iterate from n minus 1 down to 0. Back to the forward loop. In the header, you can either pre or post increment I without changing the logic in the loop body, and you might wonder if one is better than the other. Pre-increment ++ I means increment I and return the new value. Post-increment I++ means save a temporary value of I, increment I, and return the temp value. The latter takes an extra instructions unless it's optimized out. As the value produced by expression 3 is not used, modern compilers will optimize the difference away, and there will be no practical impact. However, there may be a difference when dealing with complex types like iterators in C++, but that's a whole other story. So I hope you will enjoy writing fancy for loops, but remember to keep your code clean and readable. Thanks for watching.